Alright, in this video I'm going to be showing you how to use our SigmaCheck eddy current conductivity meter. Our manual is here. The meter comes in a little handy bag like this, and we store it in our undergrad lab. So I'm going to be showing you how to use this for measuring the conductivity of our cartridge brass samples. Alright, we are going to start with the setup of the SigmaCheck eddy current meter. I've taken it out of the package. I've also plugged it into the wall. It is battery powered, but I want to make sure that the power is going to be continuous during our operation. So this is just an extra piece of insurance. So I've got it plugged in there. Next, I've got a probe for the machine. So I'm going to take the end that goes into the meter, and I'm going to insert it onto the right side, and you kind of have to rotate it around until it inserts. A little difficult. There we go. And then it rotates into position so it doesn't come out. So I've got the probe in. I've got it plugged in to charge the battery and make sure it's continuously operating. If I was doing this in person, if you are doing this in person, you'll want to make sure you have the manual in front of you. There's also a reference card here, and on the instrument itself there is some instructions about how to start up. And so we're going to start with that. And so let me bring the camera a little closer so that you can see what I'm doing. Alright, so this is the eddy current meter. The first thing I want to do, and the first thing that the instructions tell me up here, is to turn on the unit. That is the green power button here. So I'm going to click that once. You'll see that the screen turns on, goes through kind of a home screen, shows you the some specifications of the device, and then this is kind of the typical screen that you'll see. It says SigmaCheck up here. Conductivity, it gives you the units here, and then it gives you down here there's options to change this, but for now it's going to be minimum thickness, and again the units. There's no readings because we are not using the probe yet, but we've turned this on, and the second step is actually to wait. So we're going to allow this thing to stabilize for 20 minutes. So this lets the probe and the current sort of normalize to the settings of your lab. And so we're going to let it stabilize. This should prevent sort of the measurements that you're taking from drifting. So I'm going to sort of leave it here. I'm going to stop the video and we'll restart it once we've waited for this to stabilize for 20 minutes. Okay, we are back. I've got a close-up view of the SigmaCheck so that you can see the screen as we proceed with this demonstration. I've got a test piece of cartridge brass that was from a previous year, so it doesn't matter what type this is, it's just a test piece. And we're going to go through the basic operation of this machine. To review, we've turned it on. We've got the power in so that if the battery is low, it won't shut off. We've plugged in the probe over here to the side, and we let it stabilize for 20 minutes. So what we're going to do now is, the first thing you might notice is this thing blinking down here, and it says press the check mark to cal, so calibrate. And so I'm going to hit the check mark, and up here you see calibrate, and then it gives you the two values. These are the two values that are the standards that we have. And so if you look at the top here, those are the two standards that we have. It's not focusing very well, but those are the two standards that we have here. Oh, there it goes. So you can see that those values, see if it, there we go. those two values are the standards that we have. Okay, so what we are going to do then is again hit the check mark, and this will start the calibration. And it walks you through how to do this test. So that first one says hold it in air, so all I did was just, it was over here and it was ready to go. Now it says put the probe on the 100.68 value sample, and so that's the one over here. And so it has a little slot for it to go, and you just hold it flat, and you'll start to see that it holds steady. If you're not holding it steady, it will move around. So you want to make sure you hold it very steady. Now it says go to the other one, the second calibration standard, and you hold it on there. That's the 8.422. And I'll hold it, and it's ready to go. You can also go back and now that it's calibrated, put the probe on the standard and check it and see how close it is. So this one says 102.01. It should be 100. Let me check that again. Should be 100.68. So it's a couple. It's 1 or 2 points off. I'll do it again just to see where it's at. 102 again. And so this tells us that it might be drifting a bit. And so one thing we can do is check the calibration again, or we can check the other one to see where we're at. 8.46 or 47. And again, this should be 8422. So this one was actually pretty close. And so you can check these, and I would, it takes a matter of seconds to check them. So you want to frequently check those standards to make sure that the calibration is the same, it's not drifting. So you can check this periodically, especially if you're testing samples and it's over a prolonged period. So just make sure you check that probably before and after to make sure that there's been no drift. And so in this case, I might go back and change the calibration. Okay, but that's all you have to do to run tests, is just you basically place this probe onto the surface of something. We have the standards up here on top of the machine, and then we can also test this. So once we are satisfied with the calibration and with it not drifting, we are ready to test. On this home screen, like I mentioned before, it has conductivity. It has, in this case, listed minimum thickness. So this is a function of frequency and the probe that we have. And it tells us, based on the conductivity of the sample, what our minimum thickness has to be for the test sample, for this one, to ensure that we have a valid test. So you'll notice that this sample is a given thickness. If I press the probe here, you're going to see that the minimum thickness should be 0.8 millimeters based on the conductivity and based on the probe settings that we have. So if I measure the thickness of this and it's not 0.8, then we would want to, if it's not at least 0.8 millimeters thick, then that wouldn't be a valid test. And so we would want to go back and change, most likely, the probe frequency such that that minimum thickness decreases. And we'll go over how to do that. So the conductivity would be listed up here, as you might have seen in that test. We can also use the down arrow to highlight the second one. And so we always want to look at the minimum thickness for a given type of material and the probe settings you have. This should remain constant or fairly constant. So you only really need to check that probably once. But you can also, if you hit the over button over here, then we can also select other things to view. So this one is called liftoff. And so again, if I touch the probe, you'll see that the liftoff there, it says 0.0 millimeters. Liftoff basically tells us if there is separation between the conductive material and the probe. So this is useful if there's any sort of thick oxides or anything preventing the surface from being analyzed. So in this case it said 0. So basically nothing is preventing us from measuring that conductive phase, which is brass. If there was paint, if there was oxide, anything like that, that liftoff may go to some non-zero value. Just as a sort of a quick check, if I put a piece of paper over it and measure the value here, you'll see that the liftoff is 0.2 millimeters. So I can still measure the conductivity because it's going through this this non-conductive paper phase, but it tells us that we're off of the surface. So this is something that we'll always try to, at least for sampling of our test specimens, we will give you the liftoff value for that to verify that there's nothing interfering with the measurement. All right, so let me kind of keep going through this. So conductivity, you can put that up again. Liftoff, conductivity, date and time, not so useful. It can also do a metal sort feature. This isn't very useful for us because we know that this is cartridge brass, but if I just sort of select this, let's see if it actually works. Nope, it's not working for the current piece of material, but in some cases it will try to guess based on conductivity values what type of material it is. So not super useful for us, but if you have an unknown sample, you could always try that and see what happens. And then again, minimum thickness and liftoff. So I tend to leave it on minimum thickness or liftoff. All right, something else I want you to sort of know about is this units. So you can see that the unit for conductivity is % IACS. So this is a standard that uses a % of a standard that's been used, and that standard, which is what the C stands for, is copper. And so 100 used to be kind of the standard measurement for copper. And so if you have 20% of that value, that means that the conductivity is 20% of that copper standard. And so that's one of the potential units that you can use. But we can also, if we hit this back button, we can look at what we have here. So it's telling us what probe we're using, what frequency we're using. So this is something we might have to change depending on our sample. And also the last calibration date, the annual calibration date. Don't pay too much attention to this because the dates are off. We can hit back again. And let me go ahead and all right, so once I hit the back button, and let me do that again for you. So I'm starting at the home screen, I hit the back button, and then I hit down. So now I've got a list of options. You saw the calibration, frequency, if our liftoff, or sorry, if our minimum thickness isn't right, or we want to try a different frequency, we can click on that. If we end up changing probes, we would go there, but we're not going to change probes. And so the frequency is what I want to show you on this case. So I'll click this, and then we have options for other frequencies, and I can click that. Oops, sorry. And I can scroll up and select a different one if I want. All right, let me go to advanced here and show you some advanced options, alarms and so forth. The main one I want to show you is I want to show you the units and where I can do that. And let's go to configure. There it is. So if you go to configure and you go down to units, now you can select what units you have. So the % IACS, you can also use mega Siemens per meter, and you can use ohm centimeter, micro ohm centimeter. So any three of those you can use. I will tell you, if you happen to do it in one unit and you want to change after the fact, there are conversions out there that make this easy. So don't worry too much about the units. Just make sure that you determine which units you're using. All right, so I'm going to go back and just leave it in that setting. All right, so we have units, we have a quick overview of all of the quantities that this machine can give you, and we're ready to test the conductivity of our test sample here. And again, this is just from last semester. It's not important for your data. But I'm going to take the probe. I've got the conductivity and the units specified here, and I'm going to leave it on liftoff, but we can go back and forth. So I'm going to basically press it flat on the test piece and make sure that I'm not moving it around. You'll also notice that the test piece is big enough to accommodate the probe. So you want to make sure that it's larger than the probe. And so we've cut these pieces specifically such that they're bigger than this probe. And so now it's stabilized, it hasn't moved. So let me do that again just so that you see it again. There we go. So I'm going to place it on. You'll notice that it may move around initially, but it will settle on a value. All right, it's moving a little bit, but it seems to be stable at 27.23, and the units are that percent IACS. The liftoff is 0. The units there are millimeters. If I go and select minimum thickness, again it's at 0.8, so we would need to, and the units there are millimeters, so we need to verify that our sample is at least 0.8 millimeters thick. And so that's our value for conductivity on this test piece. So it's a very simple operation to go through and test the conductivity. Like I said, you want to make sure it's started. You want to make sure it can stabilize for 20 minutes before you do the calibration, and then do the calibration using our two standards located on the top. You can check throughout your measurements to make sure it's close to those calibrations. So I recommend checking the calibration before and after your measurements. And then once it's calibrated, and you're ready to go, you have the proper units and everything you saw from the settings, then all you have to do is take the probe and place it on the sample and make sure that it's resting flat and that you're not moving your hand or anything, and then you wait for it to stabilize and you record those values. So you want to get conductivity and then minimum thickness and liftoff. Those are the three quantities that we're going to be looking for. And so for your data set, I will test on similar pieces. I will give you photographs of your test pieces, and then I will give you photographs of the test when it's stabilized so that you can see conductivity, minimum thickness, and so forth, and you can sort of collect all that data for your specific data set. Alright, so this has been the video on how to use our SigmaCheck eddy current conductivity meter, and I hope you've learned how to use this.